All right, so let's see if we are live. Perfect. All right, so hello, hi, good afternoon, my dear students. How are you all? I hope that everybody is fine, and I welcome you all here at Unacademy. So I am Ritika, your chemistry educator, and today we are going to have a very important session on the organic chemistry. Now, before telling you what is our topic for today and what are we going to learn today, let's know a bit about me. So, I am Ritika, your chemistry educator. I have completed my engineering in electronics and communication, and right now I'm here teaching you all chemistry. So, I once again welcome you all. And talking about what are we going to study today, I'll be telling you shortly. But before that, students, you can join us on the Telegram channel. Okay, so if you need any assistance in the homework or your class notes, you can click on the link which is given in the description box. And also, you can follow the official channel of Unacademy. Okay, and why? Because here you will be getting the daily updates of all the classes that go on here, all the ongoing offers, all the special classes, and all the batch courses that we are going to begin, right? So you can follow these Telegram channels to stay updated and to attend the classes regularly. All right. Now, before starting, I will be telling you a bit about Unacademy's free special classes. So, first of all, what is the special class? These are the classes which go on at the Unacademy platform, and they are absolutely free of cost. That is, any one of you can watch them. All you need to have is the Unacademy Learner app. Okay, now over here you can have real-time interaction with your educators. We have various options of chats and emojis. Okay, and also you can ask the question using question tab, right? So you can either type in your question or you can even attach your image. There are these two options which are available. And then we also have one very amazing feature, that is poll. Okay, so what is poll here? Educators ask you certain questions and then you get options to choose from, and you can also have a competition with your friends. That is, we are having poll leaderboards. All right, so you will be getting the whole data of how many answers you have given correctly, what's your average timing, and what's your position among all the students. Okay, so these are some of the very special features of the Unacademy classes. Now, talking about our special class timetable. So, students, we are going to have some of the special classes. The schedule, it is listed over here, right? So, if I go for the nomenclature, okay, on 12th of February at 4 p.m., we are going to have a very important class, okay, that is a poll war, that is a question session on nomenclature. Then on 15th of February, we are going to have hydrocarbons, and 17th of February, we are going to have Viva Hustle. Okay, that is a very important session, students. Kindly don't forget to attend the sessions and also share the links with your friends so that many students can attend the session and can take the advantage out of it. All right. Now talking about Unacademy special classes and the plus subscription features. So students, what is the thing that you get in your plus classes? There are certain special things. Okay, the very first is, of course, you can learn from the comfort of your home. Okay, and you will be having unlimited access to all the courses. After that, you will be taught by top educators of India at one platform. And not just simple classes, we also have regular doubt clearing session. Okay, so in doubt clearing and answer writing session, you are told in detail how to write your answers to achieve maximum out of it. Also, your syllabus, it is covered and you are under the mentorship and guidance of your educators. Apart from this, you have your study material which is given to you in the PDF format, and we have regular practice test or live test. Okay, and the batch courses, of course, they are there. Now, apart from all of these things, you get your daily practice section, you get weekly mock test series, live quizzes, daily MCQ, and also subjective test series. So these are the various things that you are getting in the plus subscription. Okay, kindly make sure that you attend the classes, you take the subscription and take the advantage, and you take your preparations to the next level. All right, now we will be moving on to the organic compounds. Okay, I will be telling you about the pricing and how to go on for payment methods in a while. First, let's start with our question session. Okay, so the very first question is, what are organic compounds? Just a minute. Okay, so what are organic compounds? This is our very first question. So what your answer will be over here? These are the compounds. Okay, now organic compounds are those compounds which are primarily made up of carbon and hydrogen. Okay, and then they have some of the other compounds, or they can have some other elements such as oxygen, nitrogen, phosphorus, some of the halogens, etc. So what your answer should be over here? Compounds made up of carbon and hydrogen. So these are the two basic elements that are present, and carbon is the most essential one. Okay, with elements such as, so over here we can have oxygen, we can have nitrogen, we can have sulfur, we can have halogen, etc. Okay, now we will be seeing some of the basic properties of organic compounds. Just a minute. Okay, yeah, we will be seeing some of the basic properties of organic compounds. So if I go for the general things about organic compounds, what can I have? I can have, the very first is carbon is necessary, right? In the organic compounds, we have carbon, which is the most essential element. Next is the organic compounds, they generally do not dissolve in water. Okay, they are very much soluble in the organic solvents. So they are soluble in organic solvents. And what are organic solvents? We can have benzene, we can have chloroform, we can have alcohol, etc. Next property of the organic compound, it is they are having low melting point and boiling point. So their melting and boiling point, it is generally low, and also they are forming the covalent bond. Okay, so they form covalent bond. Then they show the phenomena of isomerism. Okay, and they are normally having a characteristic color and order. Okay, so they are having special type of colors and smell, that is odor. So these are the general characteristics of organic compounds, right? Let us again see what are the characteristics. These first of all, these are the compounds which are made up of carbon and hydrogen. Okay, so these are the principal elements, and apart from this we also have some of the other elements such as oxygen, nitrogen, halogen, sulfur, phosphorus, etc. Sorry. Then talking about the properties of organic compounds, here carbon is the most essential element. The organic compounds, they do not dissolve in water but are very much soluble in the organic solvents such as chloroform, ether or alcohol, etc. Then we are having low melting and boiling point for the organic compounds. They form covalent bond, the bond which is formed by sharing of electrons. We will be seeing, okay, we have certain questions on covalent bonding also. And then they show the phenomena of isomerism, and they generally have got a characteristic color and odor, right? Hope that is very much clear to you. That was pretty easy. Next, what properties enable carbon to form large number of compounds? Okay, so the carbon atom, it has got a unique nature. Okay, and this is the reason why there are such large number of compounds made up of carbon. Now, what are those reasons? Let us see. The very first is tetrahedral valency. Okay, now let us see what do we mean by tetravalency. Okay, so see, if I talk about atomic number of carbon, it is 6. Okay, and due to this, the electronic configuration, it will be 2 and 4. That means it has got 4 electrons in the valence shell. Okay, now see, since it has got 4 electrons in the valence shell, it can neither donate the electrons nor it can gain the electrons, right? So what does it go for? It goes for mutual sharing of electrons. Okay, so because of this, okay, it goes for sharing of electrons, and it forms what? It forms covalent bonds. Okay, so that is the very first property of the carbon, due to which it is forming such a large number of compounds. Okay, so if this question arises in your question paper, the first reason it will be tetravalency. Okay, and the second reason is catenation. So what do we mean by catenation first of all? Now see, catenation means if any element, okay, it is able to form chains, okay, of the same atoms. Okay, now if I talk about carbon, so carbon, it can form chains by self-linking, and that is what is known as catenation, right? It can form the chains like this, it can form the chains like this, it can form the chains like this. Okay, now talking about catenation, we are having different types of chains which can be formed. Okay, so in the catenation, first thing is it can form straight chain. Okay, so this is the straight chain that can be formed. Next is the carbon atoms, they can form a branched chain. Okay, so this is the branched chain. As you can see that there are branches which are coming. Okay, these are the, okay, this is the straight chain and then these are the branches, right? Okay, next is they can also form cyclic chains. So second property is catenation, which enables carbon to form such a huge number of atoms, right? Okay, then we have, just a minute. Okay, so after that we have the property of forming the bonds. Okay, so the third property that we can have is formation of single, double or triple bonds. Okay, now this carbon atom, it has this property to form a single, double or triple bond, due to which again it is able to form large number of compounds. Okay, so what are the three basic properties which enable the carbon to form large number of compounds? So the very first is it has a tetravalency. That means it has got a valency of 4. Now because of this valency of 4, it is neither giving out the electron nor it is taking, it is sharing the electrons. Okay, and it is forming the covalent bond. Okay, next property is catenation. Because of this catenation, the carbon, it can form long chains by linking itself to other carbons. Okay, now because of this catenation, it can form the different type of chains, such as straight chain, it can form branched chain, and it can also form the cyclic chain, right? Next is the formation of double, triple and single bond. Okay, so single bond, we are having a single bond between the carbon atoms. Just let me show you over here. So this is the single bond, then we can have a double bond, and we can also have a triple bond. Okay, so this is the type of bonding that can happen. between carbon atoms. Okay, and these are the reasons why we have so many compounds possible of carbon. All right, next is differentiate between organic and inorganic compounds. So let us see. Okay, I'll just okay, so we will be having the differentiation. Just let me, yeah, okay. So in this column we are going to have organic, and here we are going to talk about inorganic. Okay, now talking about organic compounds, they are having carbon, which is an essential element. Oh, okay, which is an essential element, and in addition to carbon, it can have hydrogen, it can have nitrogen, oxygen, sulfur, phosphorus, halogens, etc. Okay, but talking about inorganic compound, here carbon, it is not necessary. It can have, but it's not necessary that carbon must be present. Okay, then talking about organic compounds, they generally can exist in the form of gas or liquid or solid. But in the case of inorganic compounds, they generally exist as solid. Okay, now the third one is the melting and boiling point of organic compound, it is generally low. So we can write they are having low melting and boiling point. Okay, and in the case of inorganic, they are having high melting and boiling point. Okay, then talking about the organic compounds, let me write it over here again. Okay, so organic compounds, what's the point? It is fourth point. Okay, organic compounds, they generally are insoluble in water, or very, sparingly soluble in water, very less soluble in water, and they are readily soluble in the organic solvents. Okay, for example, we have chloroform, we have ether, we have benzene, we have alcohol, etc. Over here, the organic compounds, they are very much soluble in water, but they are insoluble in organic solvents. Okay, so that means they are not soluble in benzene or alcohol or ether or chloroform, etc. Correct? Now, next point is the organic compounds, generally they are non-conductors. Okay, and the inorganic compounds, they are good conductors of electricity. And the last one, if I talk about organic compounds, they are having, or they show the phenomena of catenation and isomerism. So what is isomerism? We are having questions related to that also, that we will be discussing soon. Okay, but here no phenomena of catenation or isomerism is observed. Okay, so these are some of the general differences of the organic and inorganic compounds. Correct. Now let us see what have we discussed. What are the difference? The first one, it is carbon. It is an essential element, okay, in the organic compounds. But inorganic compounds, they do not necessarily have to have the carbons. Then organic compound, they can exist as solid, liquid or gas. But inorganic compounds, if I talk about their general existence, it is in the solid form. They are having low melting and boiling point, and organic compounds, they are generally having high melting boiling point. Organic compounds, they are having low points. Organic compounds, they are not soluble in water easily, but they are readily soluble in organic solvents such as chloroform, ether, etc. But inorganic compounds, it is just opposite. That means they are soluble in water, but they are not soluble in organic solvents. Next is organic compounds. They show the phenomena of catenation, isomerism, and are not conductors of electricity. But the inorganic compounds, they do not show any phenomena of catenation or isomerism, and they generally are good conductors of electricity. Correct? Okay. Next is what is the homologous series and give the example. So let us see what is meant by homologous series. Okay, if I talk about definition, it is just a minute. So homologous series, it is a group of organic compounds. Now what is the thing over here? They are having similar structure, okay, and similar chemical properties. So the structure and chemical properties, they are pretty same. And over here, if I talk about every next, that is the successive member or successive compound, they are having a difference of CH2 group. Okay. All right. So if I talk about the alkanes, if I talk about alkenes, if I talk about alkynes, they are all coming under the homologous series. Okay, now let me tell you how is it possible. See, if I talk about the alkane. Okay, so the first member, it is CH4, that is methane. Okay, now I told you that first of all they are having similar physical chemical properties, similar structure, and the successive member, they are differing by a CH2 group. Okay, so over here if I add CH2, I will get what? C2H6. Now that is ethane. The next member, if I add CH2 over here, I will be getting C3H8, that is propane. Adding CH2 to propane, I get C4H10, that is butane. Okay, so similarly we can have the successive compounds, okay, just by adding a CH2 group. Correct? I hope that is very much clear. All right. Next, if I talk about alkene, the general formula of alkene, it is CnH2n. Okay, so the first or member, it will be ethene. Okay, that is C2H4. Okay, so that is ethene over here. Next, if I add CH2, so it will become what? It will become C3H6. Now that is propene. Okay, similarly we will be having butene, we will be having pentene, hexene, etc. So these are the members of homologous series. So they all first of all are having same general formula, right? Okay, every alkene, they are following same formula, that is CnH2n. Every alkane will be following same formulas, that is CnH2n plus 2. Okay, next is they are having similar chemical properties. Okay, the physical properties also they are changing gradually. Okay, all in all they are having similar kind of properties, and they are differing by a CH2 group. Okay, next is what are hydrocarbons and how are they classified. So if I talk about hydrocarbons, these are the compounds made up of only, now here there are only two, hydro plus carbon, that is only hydrogen and carbon. Okay, they do not have any other let's say element. Okay, only carbon and only hydrogen. Okay, so if I talk about the classification of hydrocarbons, so just let me write it over here. So if I talk about hydrocarbons, they are classified into two categories. Okay, so first is aliphatic. Aliphatic means open chain. Okay, and then we have cyclic. Cyclic means they are forming a structure of cycle. Okay, in aliphatic we further have a classification, and that is saturated and unsaturated. Okay, and in the saturated we are having alkanes, and unsaturated we are having two categories. First is alkenes and second is alkynes. Okay, so these are the basic classification of hydrocarbons. Okay, I hope that is very much clear. Now if I talk about saturated and unsaturated, let us see what do we mean by this. The saturated hydrocarbons, they will have only a single carbon-carbon bond. Okay, so they only will be having single carbon-carbon bond, and the example of saturated compound, it is alkanes. Okay, the general formula of alkane, it is CnH2n plus 2. Okay, and over here all the carbon atoms, they are having a single bond between them. Okay, so this is saturated first, and if I talk about unsaturated, here the valency of carbon, it is satisfied by at least one double or triple bond. Okay, so they need to at least have one double or triple bond. Okay, Nancy is asking, ma'am, which book are you referring? So right now, Nancy, it is just the general questions which I have picked out. Okay, it's not using any particular book, but if I go for a standard book which I generally refer, it is Selena. Okay, right now I have just picked out the questions from some previous year papers, and okay, so here it's not the in-text questions, but the book that I would suggest, it is Selena. Okay, all right, talking about unsaturated compounds, so we generally need to have a double or triple bond. Okay, if I go for a double bond, that is seen in alkenes, having the general formula of CnH2n. Okay, and so here this will be the structure that you see. Okay, at least one double bond will be seen. And if I talk about the triple bond, okay, it is alkyne. So in alkyne we generally have at least one triple bond between the carbon carbon atoms. Okay, now over here in the alkyne, what is our general formula? It is CnH2n minus 2. Okay, and here what you will see, you will be seeing one triple bond. So this is the saturated and unsaturated carbon compounds. All right, next is differentiate between saturated and unsaturated carbon, that we already did. Let's quickly revise it again. Saturated, and over here let's take unsaturated. Okay, so the very first difference is they contain carbon carbon single bond, and over here they contain carbon carbon double or triple bond. Okay, then if I talk about the valencies over here, so all the four valencies of the carbon atoms that we are having, they are satisfied by using hydrogen using a single bond. So all four valencies of carbon are satisfied using a single bond. Okay, And in the case of unsaturated hydrocarbons, the valencies of carbon, they are not fully satisfied using hydrogen. Okay, and we need to have at least one double or triple bond. Okay, and if I talk about the example of saturated compounds, it is alkenes. Okay, and in the unsaturated compounds we are having, just a minute, yeah, in the unsaturated compounds we are having the alkynes, I'm sorry, it is alkanes over here, and alkenes. Okay, if I talk about the reactions that the alkanes undergo, they generally undergo substitution reaction. So this is the fourth point you can use. They generally undergo substitution reaction. And the unsaturated compounds, they undergo addition reaction. Okay, this is the general, we can say, the difference between the compounds. Okay, I hope that is very much clear. All right, just a minute. Okay, all right, so after that, just a minute, yeah. So the next question is define isomerism. It's unsaturated. Okay, now define isomerism. So what is isomerism? It is the unique nature, okay, of carbon, we can say, by which the organic compound, they are showing different structure. So how can we define it? So it is the phenomena in which organic compounds, okay, what's the thing over here? Organic compounds, they have same molecular formula, okay, and they are having different structural formula. Okay, so we can say same molecular formula but different structural formula. Okay, their chemical properties, if I talk about, they are generally similar, okay, but they are having different physical properties, okay, because of their different structures. So their physical properties are generally differing. Okay, if I talk about butane and isobutane, okay, so yeah, if I talk about isomers of butane, okay, butane means what? It's an alkane having 4 carbon atoms. So the first structure of butane that we can have, it is CH3, CH2, CH2 and CH3. So this is N-butane or normal butane as we say. Okay, the first structure. And what can be a second structure? See, if I bring one carbon atom down. Okay, so C valencies are what? C4H10 and it will be named as isobutane. So these are the two structures of butane. Okay. Now, next question is, I hope that is very much clear. Next question is, give the IUPAC name and structure of isomers of pentane. Okay, just a minute. Yeah. So pentane, if I talk about formula, it is the alkane having the formula of C5, 2N plus 2, so that becomes H12. Now let us see how many isomers of pentane are possible. So the very first isomers that will be possible, it is the normal, that is CH3, CH2, CH2. Okay, so that is N-pentane. Okay, now the second structure that can be possible over here, if I, okay, just let's go on next page. Okay, so this is the structure. Okay, so what will be the name of this compound? See, on second carbon, we are having what? A methyl group attached. So it will be 2-methyl and butane. Why butane? Because the longest carbon chain, it is having how many carbon atoms? 4. Correct? Alright. After that, we can have another structure in which I take 2 carbon atoms and I place it in on the carbon. So that will be something like this. Correct? Okay, so over here, what will be the name? It will be either neopentane, which is the common name, or IUPAC, it will be 2,2 dimethyl. Why dimethyl? Because 2 methyl groups are present, and propane because the largest carbon chain, it has got 3 carbons in it. Correct? I hope that is very much clear to you. Now, next question. Give chemical equation for laboratory preparation of methane and ethane. Okay, so if I go for first of all methane, okay, we get the reaction which is known as decarboxylation. That is, we get it from sodium acetate. Okay, now if I'm taking sodium acetate, that is CH3COONA. Okay, I am taking sodium hydroxide. My catalyst over here, it is calcium oxide, and I'm heating this solution. Okay, so what do I get? I get sodium carbonate and methane. Okay, so students, it's a usual practice that you should follow. Always write the names of the compounds that we are taking. Okay, so we have taken sodium acetate. Okay, that is the main compound, and what we are getting from this, we are getting methane. Okay, so kindly follow this practice always. And the next is ethane. So for ethane, just there will be one change, that we will be taking, in place of sodium acetate, we will be taking sodium propanoid. That is CH3 CH2 COONA. Okay, plus NaOH. Again, same conditions, calcium oxide, heat. Okay, we will be getting what? C2H6 plus Na2CO3. Okay, now over here, if I go for the naming, so what is it? It is sodium propanoid. And here I am getting what? Ethane. Correct? So this is the reaction and the answer of the question. Okay, just a minute. Okay. Yeah, so after this we have the question, give the substitution reaction for methane. So what is substitution reaction? In which one valence it is satisfied by, or it is substituted by a halogen. Okay, so if I go for the substitution reaction of methane, first of all, the first step, I will be having methane. Okay, chlorine I'm taking, and it is taking place in the presence of UV light. So what will happen over here? I'll just show you the basic structure once. Okay, now let me show it to you. Okay, so this is my methane, correct, and this is my chlorine. What is happening is this HCl compound, okay, this HCl molecule, it gets out, okay, and we get a halogen substituted product, that is CH3Cl plus HCl. So all the steps, they actually take place in the same manner. So what do we get? We get CH3Cl plus HCl. And what is this known as? It is known as chloromethane. Okay. Now, after chloromethane, what happens? If I take chloromethane, that is CH3Cl plus Cl2. Okay, what will happen? Again, we will get CH2Cl2 plus HCl. Now that is what? A dichloromethane plus HCl. Correct? Okay. From dichloromethane, what do we get? Again, we make it react to with chlorine. Okay, just a minute. So it's again made to react with chlorine. What do we get here? We get CHCl3 plus HCl. Now this, it is known as either trichloromethane, and it has also got a common name of chloroform. Okay, and this reaction ceases when we are having the compound tetrachloromethane. Okay, so over here what we'll have, we will have CCl4. That is, all the valencies are satisfied by using chlorine, plus we get HCl. Now this is either known as tetrachloromethane or carbon tetrachloride. Okay, and here the reaction ceases. Okay, hope that is very much clear. Next question is, give the reaction for oxidation of ethane using potassium dichromate. Okay, it is acidified potassium dichromate that we will be using. Okay, so if we take ethane, that is C2H6 ethane. Okay, and if we make it to react with K2Cr2O7, which is acidified. Okay, I'll just write it first over here. Okay, and it is going for oxidation. So what do we get? We get alcohol. Okay, so from ethane we got, that is ethanol. Okay, when it further goes for the oxidation using the same potassium dichromate, I will be getting what? I will be getting aldehyde, that is ethanol. Okay, the formula will be CH3CHO. After this, if it again goes for oxidation using same, we will be getting what? We will be getting ethanoic acid, that is CH3COOH. Correct? Now what did we get over here? Let's see. So first of all, we had alkane. From alkane we got alcohol. From alcohol we got aldehyde. I'll just write it over here. From aldehyde we got the acid. Okay, so this is the basic chain that we see. All right, I hope that is very much clear. Now next question is, define polymerization of ethene. Okay, we are talking about ethene. So polymerization reaction is reaction in which the same molecules, they actually join with each other and they are forming a kind of long chain. Okay, so what is it? It is a process by which molecules of ethene, we are particularly talking about ethene over here. Okay, so molecules of ethene join together. Okay, and when they continuously join together, they form large molecules. Okay, and this reaction, it takes place at high temperature and pressure. Okay, and what do we get? We get polyethene. Okay, so let's take n compounds, n number of molecules of ethene, that is CH2. Okay, now over here we are giving high temperature. Next condition is high pressure. Okay, and the catalyst are organic peroxide, or we can have H2SO4, etc. So let's write H2SO4. Okay, so what do we get? We get H2CCHN. Okay, and that is known as what? It is known as, just a minute. Yeah, that is known as polyethylene. Okay, it is actually a polymer, right? Hope that the process of polymerization is very much clear to you. And now the next question is, give general method of preparation of ethyne. Ethyne means what? A triple bond. So if I talk about the general preparation, we can get it from methane. And how do we get it? Let us see. So two CH4 molecules we have taken, that is methane. Okay. uh, when it goes for thermal decomposition, okay, with electric arc, okay, so it is 1500 degrees Celsius high temperature in electric arc, it gives what? It gives ethyne. And that is the basic or the general method of preparation of ethyne. And here we get the triple bond molecule plus hydrogen. Okay, so that is the general method of preparation of ethyne. Okay, now the next is, give the IUPAC name of the following compounds. Let us see. We will be having some of the general compounds. Okay, and this question we will be doing at last, but before that I want to tell you a very important information about Unacademy Prodigy. So students, Unacademy Prodigy, it is for class 7 to 12 learners. You can win amazing scholarships and prizes while testing your knowledge in mental ability. Now students, this test, it is scheduled to happen on 13th of February. Okay, you can enroll yourself right now for the free of cost. Okay, and you can win amazing prizes. Now I'll just help you with the schedule. So as I told you, the test is scheduled on 13th of February. So for students of grade 7 to 10, your test is to happen on 12 p.m. Okay, that is 12 noon. Kindly make sure that you sign up for this, because you are going to win amazing hampers, exciting rewards, scholarships and whatnot. Okay, so the first ranker will be getting a MacBook Air. Then if I talk about the ranker 2 to 3rd, second and third ranker will be getting an Apple iPhone. The ranker 4 and 5 will be getting an Apple iPad. 6 to 40 rankers will be getting Amazon Echo Dot. Rankers 41 to 100 will be getting Amazon vouchers. Also students, if your rank fall between 1 to 10, you will be getting 100% scholarship. If your rank falls between 11 to 25, you get 75% scholarship. If you will be getting the rank between 26 to 100, you get 50% scholarship. Rank between 101 to 200, 25% scholarship. And rank between 201 to 500, 15% scholarship. Okay, so kindly make sure that you enroll in the Unacademy Prodigy. And also if I talk about some of the upcoming batches, okay, so these batches first of all are very important from your term to examination point of view, right? As you know, your examinations are going to start very soon. So therefore, Unacademy has started the crash course batches. This is the ACERS all subject batch having delivery in English. Okay. Now students, if you subscribe for grade 10, you will be getting subscription of grade 11 and 12 absolutely free of cost. So this is a very amazing opportunity, students. Kindly avail it and take the advantage. Now let's move on to our next question, that is the IUPAC name. So I will be giving you compounds and we will be trying to name them. Okay. So the very first compound it is okay. So this is our first compound and let us see how are we going to name it. See, the first of all we have to select the longest carbon chain, and of course this is a longest carbon chain. How to start numbering? Yeah. So this is the longest carbon chain over here. Okay. Yeah. Now how to start numbering? So as you all know that we start the numbering in which the functional groups or the additionals, they are getting the lowest number possible. Okay. So over here, if I talk about this one numbering, it will be 3 and 4. okay, in which we are getting the substituent groups, and the second is 2 and 3. So of course 2 and 3 is lower, so we go for 2 comma 3 and 2 methyl groups, so it is dimethyl. And what is the longest chain? It is pentane. So that will be its IUPAC name. Second question is, okay, so this is our compound. Now let us see what's the longest chain first of all. So we are having this as our longest chain, right? The straight one. Now over here, see the functional groups or the substituents, they are this and this. So it is coming either on 2 and 3, 4, 5, 2 and 5 or 3 and 6. So of course we will be going for what? 2 and 5 since they are the less one. So the IUPAC name of this compound, it will be 2 and 5. So 2 comma 5 dimethyl. Why dimethyl over here again? Because 2 times we are getting the methyl group, and the longest chain 1 2 3 4 5 6 7, 7 carbon atoms. The chain, it is heptane. Okay, so that is the answer of this question. Okay, I hope that is very much clear. Now let's move on to the next question, which asks that. Okay, so over here we are having, okay, so over here it is, okay, let's see how to name this compound. Okay, now over here, see, if I go for the longest carbon chain, okay, let me change the color. Yeah, so it can be, see, one is 2 carbon atom, 2 3 4 5. Okay, and the second one can be 1 2 3 4 5 and 6. So basically this will be the longest chain that we will be selecting. Correct. Now according to this chain, what are we having on the, yeah, on the, here from, if I start numbering from here, I will be getting the group on carbon number 3. Okay, and if I start from here, I will be getting it on 4, which is of course not correct. So I will be going for what? I will be going for 3. So it will be named as what? It will be named as 3. And on third carbon atom, which group I am having? I am having 2 carbon atoms group. Okay, so it will be named as what? Ethyl. And what is the longest chain that is being shown over here? 6 carbon atoms. So that is hexane. Okay, I hope that is very much clear. Now let us go for the alkenes and alkynes. This is fourth one. Okay. All right. So let's go with this CH3, C, triple bond, C, and CH3. Okay, now over here students, you can see that there is a triple bond. That means it is an alkyne. Okay, how many carbon atoms are present over here? It is 4. That means but. And what is the triple bond? Like triple bond is placed on which carbon atom? So it is placed on second. So but 2 ine, YN. Okay, that will be the IUPAC name. Correct? Okay. Next is CH3, CH. Okay. Now over here you can see there is a functional group OH. So OH is the functional group alcohol, and over here if I go for the suffix, it is OL. Okay. And there is again one substituent which is CH3. Okay, now what will be the name of this? We will be starting numbering, of course, from here 1 2 and 3. So we will be naming it as, on 2 we are having methyl. The longest chain is 3 carbon, propane. Okay, and on 1 carbon we are having the hydroxyl or alcohol group, that is OL, that is the suffix. So 2 methyl propane 1 ol. That is the correct answer. All right. Yes, Samrit, that is correct. Okay, next question that we are going to have over here. It is, just a minute, it was 6th question. So over here, let's see, we are having CH3, CH, and over here we will be having CH3. Okay, now let us see what will be the name of this structure. Okay, if I go for the numbering over here, see, over here, what is the longest chain I can get? This is the longest chain that I am having. Okay. Now, how will I start numbering? Okay, if you think that we can start the numbering from, we are having 1, 2, 3, 4 and 5 carbon over here, and we are having 1, 2, 3, 4, 5 and 6 carbon over here. So we cannot take this. Why? Because if we take this, this will not be coming under the main chain. That is the wrong thing. Okay, we should be following the rules of IUPAC nomenclature. Okay, now how to name over here? We will be starting. See, on the first carbon, we are having the alcohol group, that is OL. On second, we are having the group ethyl, and on fourth, we are having methyl group. So we will be writing, moving alphabetically. So it's 2 methyl, 2 ethyl. So it's 2 ethyl. Then on fourth carbon, we are having methyl. Okay, and what is the longest chain? 5 carbon, so it is pentane, and on 1 we are having alcohol, so pentane 1 ol. That is the correct answer. Hope that is very much clear. Okay, next is, okay, so we'll be taking one more question. Okay, so over here our question is CH3, CH2, CH2, CH3, and okay, and let us write over here. Okay, 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 Samrit, how ethyl? Okay, previous question. See, on second carbon we are having 2 carbon as substituent. Okay, so for 2 carbon we are using ethyl. Okay, and here it was 1, so we used methyl. I hope that you got it. Okay, now over here, see, this is our basic structure. Okay, now the first carbon, it can get chlorine also, and it can start the numbering from here also. Okay, but since ketone is present, okay, this is the ketone group, and which is having suffix as ONE. Okay, so it gets the more priority, and what will be the name? So 1, 2, 3, 4 and 5 carbon, so it will be 5 chloro. Why? Because we will start numbering from the side which gets ketone as the lowest number. So 5 chloro, 5 carbon, so pentane. On second, that is the ketone group, and the suffix is ONE. So 5 chloro, pentane, 2 O. Okay. Ketone is not in syllabus. All right. So we did only one IUPAC nomenclature of ketone anyway, right? So that was the IUPAC nomenclature questions. Students, I hope that you might have understood everything. You can subscribe to the channel of Unacademy, and if you need the PDF, you can also download it. Also, you can join the Telegram channel. The links are given to you in the description box so that you can have regular updates of the session that we have. If there is any feedback, any query, please let us know, and we will be meeting in the next class, in which I will be bringing some of the more sessions, okay, related to your term 2 syllabus. Okay, so thank you everyone. Let's meet in the next class. Till then, please keep studying, keep learning, take care, and crack your exams with